Long before the theory of gravity was a glimmer in Isaac Newton's imagination, the natural physics of density and buoyancy already perfectly explained why apples fall down. Quite simply, objects fall or rise based on their relative density to the medium surrounding them. Apples fall because they are denser than the air, while helium balloons rise because they are lighter. No gravity necessary. This is why raindrops fall down through the air, and air bubbles rise up through water. Everything seeks its relative density, and rises or falls until settling accordingly. This is why a tiny pebble sinks to the bottom of the ocean, but gigantic cruise ships and aircraft carriers stay afloat on the surface. Because even though a pebble is so small, its mass, relative to its volume, its density, is more than water, so it sinks. And even though a cruise ship is so large, its mass, relative to its volume, is less than water, so it floats. If Newton's apple had landed in a puddle instead of on his head, he would have seen the apple only fell through the air because it was denser than the air, but then floated on top of the water because it was less dense than water. Have you ever noticed how it's easier to stay afloat with your lungs full of air than it is when they're empty? Submarines float on the surface when their ballast tanks are filled with air, but when the vents are opened and seawater floods in, they begin to sink as the submarine's density becomes greater than water. Depending what depth they wish to dive, sailors simply adjust the ratio of air and water in the tanks, and when ready to resurface, they blow compressed air into the tanks, forcing the seawater out, lowering the density, and thus causing them to rise back to the surface. We can also prove this fact of relative density by filling a plastic balloon with approximately half helium and half air. Since helium is lighter than the oxygen, nitrogen, and other gases that compose the air around us, filling a balloon with just the right amount of helium to compensate for and balance out the density of the plastic results in a gravity-defying, levitating balloon at equilibrium that neither rises nor falls. Skeptics often ask, if gravity doesn't exist, and objects simply fall down because they are denser than the medium surrounding them, why do objects of varying masses all fall at the same rate? If there is no gravity, why does a helium balloon fall down in a vacuum chamber? And without gravity, why exactly do things fall downwards when dropped, rather than upwards or sideways? To begin with, a feather and an anvil will both fall at different rates because one is radically denser than the medium surrounding, air, while the other is not. Imagine a dandelion seed and a brick, or a piece of paper and a boulder. These examples and many others fall at drastically different rates, debunking the supposed uniform speed of acceleration due to gravity of 9.81 meters per second squared. This phenomenon would be more accurately titled the maximum acceleration towards density equilibrium. As long as something has enough mass and is aerodynamic enough to negate the air resistance, things will fall through air at approximately the same rate. But if we change the medium, from air to water for example, objects will no longer fall at the same rate, again debunking this supposed gravitational constant. In a vacuum chamber, the medium of air is removed completely, so all objects, including a feather and a bowling ball, will fall at this same maximum rate. By removing the medium from the equation altogether, all objects, including a helium balloon, will fall to the ground simultaneously. Without any medium to move through, the fall rate of all objects is indeed equal, but this has nothing to do with some mythical attractive pulling force, and everything to do with the fact that the density of the surrounding medium has been reduced to zero. Therefore, in reality, since a feather, bowling ball, or anything else inside a vacuum chamber is infinitely denser than empty space, which has a density of zero, it all falls at the same rate of 9.81 meters per second squared, which is actually the constant fall rate of matter in empty space, or maximum acceleration towards density equilibrium, but not a uniform speed of acceleration due to gravity. As for why objects fall downwards when dropped, rather than upwards or sideways, firstly, there is a pressure gradient formed by the amount of stacked air, water, and land over you in a column, which increases the pressure, weight, and density the farther down you go, and that defines direction. Secondly, helium balloons fall up, not down, proving there is no downward directional bias. You can also prove this point by throwing various kinds of rocks, including pumice, into a pond. All rocks, excluding the pumice stone, will sink to the bottom. But then when you throw in the pumice, it will rise right back to the surface. This is because pumice has a density less than water, just like helium balloons have a density less than air. Their relative density, being lower than the medium surrounding, causes them to rise, just as things with a relative density higher than the medium surrounding causes them to fall. This is all perfectly explained by the natural physics of density and buoyancy, which was well known and understood long before Sir Newton renamed and remodeled it to fit with his heliocentric theory of the cosmos.